Algebra 1, 11.6a, add or subtract radical expressions. Now, I need to say this first. You need to watch video 11.5a and 11.5b, and the links to these two videos are in the description of this one. To fully understand this video and what we're talking about, you need to understand dividing rationals and rationalizing the denominator. If you don't know what that is, you're not going to understand this video, okay? So, if you do know what those are, we'll move forward. When we have radical expressions that have the same radicands, we can simplify by using the distributive property, but the radicands must be the same. So we can add, whoops, sorry, this is an addition symbol that got rubbed out. We can add these two together with the distributive property and do 4 plus 3 with this square root of 5 because they're the same here. See that? And we would end up with a 7 here. See? And what this means is, when you see the 4 in front of the square root sign, it means 4 times 5. And because that was a nice square from 16 times 5, or 80, and it was factored, well, what they do is they pull one of these out from this nice pair, and they put it in the front, and then the 5 stays inside the square root sign, see? And for this one, it's 3 times 5, and because that was a nice pair right here, they pulled one of them out and kept the 5 in the square root sign. And that's exactly what this is. It means 7 times 5, and 1 got pulled out because there's a pair here. We can pull it out and put 1 in front and leave the 5 under the square root sign. See? So that's why we were able to do this. Now, if it's not the same number under the radicand, we cannot add them like this, okay? They're talking about having the same radicand and then adding these coefficients, okay? So let me show you that real quick. The number in front of the square root sign is a coefficient just like in front of a variable. And there can even be an invisible 1 there that can help us. And you know that the little number up here is called the index. Sometimes it's called the order. And you would see that if there's like a cube root, right? And this bar up here is the vinculum, and this check mark is actually the radical sign, but you'll see it written like this all the time, okay? So remember, there's an invisible 1 there that can help us, all right, as a coefficient. So sometimes we'll need to simplify the radicand before we can add or subtract. And if we have the square root of 2 minus the square root of 8, what we can do is we can split this one into a 4 times 2. Because the 4 is a perfect square. We try to find the biggest perfect square we can pull out of here. And that would be 4 times 2, which would be 2 times 2, and that would give us a nice pair, wouldn't it? So we can take one of these, stick it up in front, and the only thing that's left is that one, and he stays underneath the radical sign, see? So we pull one of the pair and put it up here. Now, because there's an invisible 1 here, and we're subtracting, we get 1 minus 2, square root of 2. And 1 minus 2 is a negative 1. We don't have to write that 1, do we? So we get negative square root of 2. See how I did that? We simplified that 8 first into a 4 times 2. It was a perfect square, so we pulled 1 out, put it in front. We did our subtraction. Let's try it again. Now we've got the square root of x plus the square root of 4x. So this 4 is a perfect square, so we can split it into a nice little pair, can't we? 2 times 2. We can pull 1 and put it in the front and leave the x underneath this sign. See? The radical sign. Now we can add them. We got an invisible 1 here, don't we? So we do 1 plus 2, and we get 3, and then the square root of x. See? That was easy, wasn't it? All right, they're going to get a little more complicated. Sometimes we need to factor first. So here's our problem. And we need to factor this, and then we need to factor that, and then we can add them, okay? Because there's an addition symbol right there. So the first one factors as the square root of x squared times x minus 1. And this one factors as 4 times the square root of 4 times x minus 1. You see they both have the x minus 1? Well, here's a perfect square, x squared. That means x times x, doesn't it? So we can pull one of these out and put it in front and keep this guy underneath the radical sign, x minus 1. And 4 is a perfect square. That's 2 times 2. We can pull one of them out, put it in the front, and put this guy here under the radical sign. See? Now we can add them, and we get x plus 2. Now, it's not 2x, because that means multiplication, doesn't it, when they're next to each other? And that's not what this is. This is addition. So it's going to stay as x plus 2 square root of x minus 1. See? So we factored first, all right? Sometimes after we rationalize the denominators, we can factor and combine expressions. So on this one, we've got the square root of 3 plus the square root of 1/3. I can write them both with their own little sign, radical sign, right? So this is basically the square root of 3 over 1, isn't it? It's the same thing. So what we do is we want to rationalize this denominator to remove this square root sign. So we multiply this square root of 1/3 by the denominator over the denominator to rationalize it, and we get the square root of 3 over the square root of 9. See? And the square root of 9 is a 3, so now we've got the square root of 3 over 3. Now they need common denominators, so we need to have them both have a 3. So we're going to multiply this numerator and denominator by a 3, and we get 3 square root of 3 over 3, and there's an invisible 1 here, isn't there? So we get 1 square root of 3 over 3. Now we can add them. 3 plus 1 is a 4 over 3 square root of 3. See how I got that? Make sure you rationalize the denominators if they're different, okay? Do that first, then find the common denominator. All right, now here's a odd-looking one. This is a subtraction problem, and this looks like the reciprocal of that one, doesn't it? What we do is we rationalize both denominators one at a time. So that means we're going to get rid of this radical symbol because we're not allowed to have a radical symbol for a denominator, okay? So we're going to multiply the numerator and denominator as a 1 as a denominator over the denominator, see? And we're going to do the same thing for this side. We're going to multiply it by the square root of 5 over square root of 5 as a 1 to rationalize that denominator. And that gives us the square root of 15 over the square root of 9, right? And this gives us a square root of 15 over the square root of 25, and that's the square root of 15 over 3, isn't it? Square root of 9 is a 3, and the square root of 25 is a 5. So really, you don't need to do this step. All you have to do is multiply them by the denominator over the denominator and just pull the radical sign off, okay? Because you're doing 5 times 5 and you're doing 3 times 3, so that is the square of it, see? So now, this is our problem. But we need to find a common denominator, and they can meet at 15, can't they? So we're going to multiply this side by a 5 over a 5 to get to a denominator of 15. We're going to multiply this side by a 3 over a 3 to get to a denominator of 15. And you don't have to actually do the multiplication because we're going to do this. We're going to leave the coefficient there and add and subtract the coefficient, see? Because they've got the same radicands. So 5 times the square root of 15 ends up being written as 5 in front of that square root sign like that, just like we did in the beginning of the video, see? And this one would be 3 in front of that square root sign. See that, how we did that? Now, because they have the same denominator, we can subtract them, and we have 5 minus 3. 5 minus 3 is a 2, and our answer is 2 square root of 15 over 15. See? See how I did that? So we rationalized the denominators first, separately, got rid of that radical sign, then we multiplied them by something to get them to a common denominator, and we kept them in that multiplication form. We didn't actually multiply them and do 5 times 15 and get 75. We didn't have to do that. We just put the 5 in front of the radical sign. We put the 3 in front of the radical sign because they both have 15 under a radical sign. Now we can just do 5 minus 3, see? Now, these can be very confusing, and some of them aren't as straightforward as this subtraction problem. So, our next video, 11.6b, we're going to do more subtraction of radicals that are written as rationals with unlike denominators. And if you'd like to review those 2 important videos, You can just click on the link and go to them, along with other videos that might help you. If you think you're missing something and you have a hole in your education, you should fill it in so that you don't get lost, okay? So you wouldn't want to watch a movie and miss 20 minutes of it and then wonder what happened in the story, okay? Then you're asking everyone around you, what happened? What happened? That's not fair, right? Okay, I'll see you next video, and we'll do some more subtraction. Bye.